Here we go. Okay. So, first thing I want to do is just remind you guys of a couple of vocabulary terms. This, x plus 2 over 2x squared plus 4x plus 4, this is called an expression. Because it has no equals. An equation is more like this. X plus 2 over 2x squared plus 4x plus 4 equals 1. This now becomes an equation. Right? So the difference between an equation and an expression is the equal sign. Equals equation. Right? And so up until now, we've really been focusing mostly on rational expressions. And all you can do with an expression is simplify it. With an equation, we can typically solve our equation. Now, if we were to talk more in detail about this, I could remind you guys that you can only solve one equation with one variable. When you have two variables, you can graph it, right? If you have two variables and two equations that are different, then you can solve as a system. If you have three variables and three equations, you can solve that. And so we could go into all the different types of systems of equations. But for now, we're just really making the difference explicit between an expression and an equation. So here's an example of a rational equation. 6 over x plus 4 equals x over 2. And now, the instruction here is going to be solve. Solve has an E on the end. Solve. Okay? Instead of simplify, we solve. Now, often, and it's not the case here necessarily, but often you might want to think about simplifying first. So you can think of this equation as two expressions. And if I could simplify this expression, I would. If I could simplify this expression over here, I would. So this equation is made up of two expressions. In this case, I'm not going to bother with any sort of simplification. I don't see any greatest common factors. The numerator here is very simple already. The denominator here is very simple already. So instead, I'm just going to try to solve for x. I'm going to try to get all my x's on one side and then divide by whatever coefficient is left. Or we might have to deal with a quadratic. In which case, how would we solve a quadratic?
Find zeros. Yeah.
We'd try to factor it and find the zeros, essentially, right? Okay, so here we go. Sal is telling us to cross multiply this. So what we would have then is 12 equals x times x plus 4. Are we going to have a quadratic here?
Probably.
Yes.
Yes, we definitely are. If I distribute this, now this is already factored, right? But the problem is that it doesn't equal 0. And in order to solve a quadratic, we have to have it equaling 0. So I need to unfactor it. 12 equals x squared plus 4x. And then set it equal to 0. 0 equals x squared plus 4x minus 12. Now I'm going to try to think of factors of 12 with a difference of 4. What could those be? 6 and 2. Which one's going to be positive? Which one's going to be negative? x plus 6, x minus 2. 6 times negative 2 equals negative 12. 6x minus 2x equals 4x. So that checks out.
That checks.
That checks. And now I can just use my shortcut, right? The additive inverse here, x is either going to be negative 6 or 2. I could have also written this out, so here's the step that I skipped. 0 equals x plus 6 or x minus 2. So either here I would subtract 6, x would equal negative 6. Here I would add 2, x would equal 2. Right. But hopefully by now you guys are pretty good at looking at this and seeing, oh, of course, x would have to be negative 6. Right? It's the additive inverse of 6. Or here, x would have to be 2. So I have two solutions. Right? X could either be negative 6 or it could be 2. And we can check this by plugging it back in. So let's check our work by plugging it back in here. 6 over, let's use the negative 6 first. Negative 6 plus 4 equals negative 6 over 2.
6 over negative 2.
And this would be 6 over negative 2 equals negative 6 over 2.
Negative 12 equals
Negative 3 equals negative 3. These are the same thing. So that checks. Let's also try plugging in our 2. 6 over 2 plus 4 equals 2 over 2. 6 over 6 equals 2 over 2. 1 equals 1. That also checks. Okay. It's definitely worth checking your work with these, because there's a lot of mistakes that you could have made along the way. All right. I think probably for today this is good. You can probably see where we're going to start going with this, in that this was a very simple rational expression. We could have started with something more complicated, right? Something that had to be simplified. Or we could have started with two fractions that had to be combined.
Yeah.
So you would have to use those adding rational expressions. But for now,
It's simple.
for now, we're just going to kind of stick with these simpler ones. I will write the homework up here before stopping the video. Please write it in your notes as well.
Wait, is that the notebook?
So your homework will be page 823, numbers 3 through 12. So let me make sure that we leave that tight.
7.
Three to 12. Is that it?
Yeah, actually, let's just do 3 through 11.
Is that it?
Numbers 3 through 11. 12 is kind of weird. It's like an error analysis problem.
Do you want to?
And then, yeah, I will collect your homework. And then I'd like you guys to try page 826. This is kind of more review. Numbers 1 through
1.
5. 1 through 5.
Bit trick.
Okay? And that'll be your homework for tonight. And somehow the camera has gone totally out of focus. There we go. Alright. We can stop this.